All right, guys, this is Mr. H. This is the fourth linear regression from the packet that I gave you. All right, so basically we've got students who are taking their prep class for the SAT, and this is telling the number of classes that they've attended, and this is their score based on those classes. So what we're trying to do is we're trying to come up with linear regression for this, and we want to know the correlation coefficient. How strongly are these two variables related? So let's do it. Just as before, I've already entered all of the data. So remember the X and Y, you got to put that at the top, put the data, make sure you enter that, double check it, because that's where most students mess up. Then you're going to go here, down here, you're going to put an X over here, you're going to put a Y, boom, done. And now you're just going to, now the fact that this is over here, don't trip, just, it's still a linear regression. So it's going to be menu 461. We don't have to do anything else. Here's the equation. Now, according to this, we're going to round the linear regression to the nearest hundredth. That's 2 decimal places. And we're going to state the correlation coefficient, and we're going to round that to the nearest hundredth as well. So let's do that. So if we do that, if you see the slope 40.476, so this 6 is the number. It's 5 or above, so we're going to add 1 to the 7. So it's going to be 40.48, and then we got to put it times x. So it's going to be y equals 40.48x. And now we're going to come over here to the y-intercept, and it's going to be 363, and we got to round this to the hundredths place. The 0 is in the hundredths place, so you look to the right, it's a 9. So you're going to add 1 to the 0, so this is going to be 363.81. All right, so this is your equation. This is what you should write. 40.48 to the times x plus 363.81. This is 2 points. If you can round it and you put the come up with the equation like that. Now the second part, we have the correlation. This is the r squared. This is not the correlation coefficient, but when we take the square root of this number, it's going to give us the correlation coefficient. So r squared, I'm just writing it on my iPad so I can take this number. It's 0.0706944716. That's enough numbers. You don't have to write the whole thing in here. That's enough. Do about 6 or 7 numbers. You should be good. So now I'm going to go here and I'm going to enter that number. So right here, I'm going to do 0.706944716. All right, press enter. That's the r squared. Now we're just going to take the square root of the r squared to get the correlation coefficient. So I'm just going to go get this number and copy it in there, press enter. There is our correlation coefficient. We got to round it to the nearest hundred. So 4 is in the hundreds place. There's a 0 to the right. So we're going to let all this shit go. It's just going to be 84 cents, 0.84. And then that's still strong. Anything above 75 cents is strong. So this is strong positive correlation. How do I know it's a positive correlation? Because the slope is positive. So I'm just going to say strong positive correlation between the two variables. Boom. That's it. We're done. Now this is 2 points. This is 1 point. This is another 1 point. That's an easy 4 points. We got to get them. I'm going to stop and